Let's talk about this question number 16 of exercise 5. A vessel is lying in a river berth of density 1.010 tons per cubic meter. So vessel is in river berth. RD is 1.010. Well, it is tons per cubic meter, so RD will be 1.010. With her summer load line 20 mm above the water on the starboard side and 50 mm above the water on port side. So let's have this vessel in athwartship direction, that is port side here and starboard side here. And suppose this is the summer load line, SLL. This is the summer load line, and the question says that summer load line is 20 mm above the water on starboard side. So let's say that this is the water line, and water line is here, so this is 20 mm above. Here the summer load line is 20 mm above the water line and on the starboard side, and 50 mm above here. So this is 50 mm above the water line. So we can write that this is the water line, which is a bit inclined. So the mean distance of summer load line, let me put it this way, mean distance of summer load line will be 20 plus 50 divided by 2. So this is 70 and divide by 2, which is 35 mm, and obviously it will be above water line. We can write in centimeter, which is going to be 3.5 centimeter above water line. Make sense? Yeah. So find how much cargo she can load to bring her to a summer load line in salt water if her summer draft, well, if her summer displacement is given, displacement summer in salt water is given, which is 15,000 tons, and the TPC is given, which is 25. Actually it's 25 ton per centimeter. Well, we know the formula for freshwater allowance, that freshwater allowance is equal to W, which is displacement, upon 40 TPC. W upon, just let me go through the formula again. Okay, W upon 4 TPC, if this is in millimeter, this is in tons, and this is in ton per centimeter. We can write 15,000 divided by 4 into 25, which gives me, this is 100, so it is 150 mm. Now let's find the dock water allowance. The dock water allowance is change of density 1025 minus vessel is in river port, RD is 1010, so 1010 divided by 25. We could have written 1.025 and 1.010 divided by 0.25, or simply just 1025 and 1010 divided by 25 also makes sense, and this is 150. Well, this is 25 minus 10, which is just simply 15 divided by 25, into 150. Now all we have to do, use this calci. Here it is 15 multiplied by 150 divided by 25 is 90 mm. 90 mm, or simply 9 centimeter. Now the question says that find how much cargo she can load to bring her to summer load line in salt water, and we have got two information. One is summer load line is 3.5 centimeter above the water line, and dock water allowance is 9 centimeter. The TPC given is 25. So what we do, let's draw these load line marks, and which are like this: tropical, summer and winter. And also as rough sketch will do, this is F, that is freshwater mark, and this is TF, tropical freshwater. So where is the water line? Water line is somewhere here, because the summer mark is above the water line. Let's have a look at the question. The mean distance of summer load line is 3.5 centimeter above water line. So this distance is 3.5 centimeter above the water line. Now, what is the dock water allowance? The dock water allowance is the distance between F and S mark. So this is the dock water allowance, which is 9 centimeter. So if the vessel was in salt water, we'll use only this sinkage. However, vessel is in dock water, so we use total mean sinkage. Total mean sinkage in centimeter is 9 centimeter plus 3.5 total distance. So 9 plus 3.5 is equal to 12.5 centimeter. Now it's very simple. Cargo to load, that is the dead weight available, is equal to mean sinkage in centimeter multiplied by TPC. However, you need to convert TPC. TPC depends on the draft, so the TPC depends on the density, and the TPC density is 1.010. So the TPC for 1.010 will divide by TPC for salt water is equal to 1.010 divided by 1.025. This simply means that TPC 1.010 is TPC salt water, which was 24, I believe. Yeah, 24 multiplied by 1.010 divided by 1.025. If you want, you can use the same value here. So mean sinkage in centimeter was 12.5, and the TPC is 24 into 1.010 divided by 1.025. You can directly obtain the answer. So let's use this calci. Put it 0 multiplied by 12.5 multiplied by 24 multiplied by 1.010 bracket close divide by 1.025. So we get 295.6 tons. Oh, there has been some mistake. The TPC value is 25 actually. This is 25. Let me just correct. 25. The value of TPC is 25. Yeah. the TPC is 25 ton per centimeter. So I'm going to just correct this value. We can do it this way again. Simply 25 multiplied by 1.010 divided by 1.025 gives you 24.634. that is the value of TPC. Now you multiply it by sinkage 12.5, it gives me 307.9. so I correct this value and make it 307.9 ton.